Hello and welcome back to Josh Does Math. In this video we're going to be doing some problems related to limits and limits that involve multiple functions. So as you can see we're given here, if the limit as x approaches a of f of x is equal to 4, and the limit as x approaches a of g of x is equal to negative 2, and the limit as x approaches a of h of x is equal to 0, then evaluate all these limits here. So as you can see, these limits are made up of multiple functions here, so we're probably going to be using some of those limit rules where you can add and subtract and multiply and divide functions. So let's look at the first one here. Limit as x approaches a of f of x minus g of x. So we're subtracting two functions here, and according to the limit rule, we can just distribute this limit to each of the two functions. So this is going to be equal to the limit as x approaches a of f of x minus the limit as x approaches a of g of x. And that's just a rule that tells us we can do that. And this is going to be equal to, well, we know the first one is 4, and we know the second one is negative 2, so that's going to be plus 2. So that will give us 6 as the limit for part A. For part B, we're looking at the limit as x approaches a of g of x squared. So you can think of that as just g of x times g of x. And we have a limit rule for that. Similarly to how you distribute the limit to each of these two terms here, it's not really distributing, but it works in the same way where the limit gets applied to the first g of x and also applied to the second g of x, and you just multiply those two together. So I'll write that out. This is equal to the limit as x approaches a of g of x times the limit as x approaches a of g of x. So you can see how we just apply the limit to each of the two things being multiplied together, and then multiply that result. And we are given that limit as x approaches a of g of x is negative 2. So negative 2 times negative 2, well, that's 4. So that's the answer for part B, 4. So now we have a quotient here that we're looking at. And for a quotient, you want to be careful that you don't get 0 in the denominator, or else you can't say what that limit is. But right here we have the limit as x approaches a of f of x over g of x. And similarly to what we did with the product of two functions up here, if two functions are divided, you just apply the limit to each of those two functions. So we have limit as x approaches a of f of x over limit as x approaches a of g of x. So this is going to give us 4 over negative 2, and that's just going to give us negative 2. For the next one here, we have another quotient, so I'm going to set it up the exact same way. And I'm just going to plug in the values that I was given over here. So I'm given limit as x approaches a of h of x is equal to 0. So I have a 0 in there. It's not in the denominator, so far so good. Limit as x approaches a of f of x, and I'm told that's 4. 0 divided by 4 is 0, so there we have that limit. And another quotient. So far we're starting to get bored of these quotients, so see if this one is a little harder. So I'm just breaking the limit up, and I'm plugging in my values. It's the same exact values as these, except for it's in reverse order, and now we have a problem. We have 0 in the denominator, and normally if you were to approach 0 in the denominator from the positive direction, in other words, this number down here, the 0 is actually equal to 0.00 ... 1. If that were what was down here, we could say that, well, you're dividing 4 by a number very, very, very close to 0, so it's equal to infinity as your limit. And the same thing, or a similar thing, could be said if 0 was, let's say you're approaching it from the negative direction. So this is 0 is equal to negative 0.000001. well, then you could say this would be equal to 0 divided by a very small negative number. That would be negative infinity. But the fact that we don't know from which direction 0 is approaching, and we don't even know if the limit is defined at 0. It could be oscillating at 0. So whenever you see this case of 4 over 0, or some number divided by 0, and you're not approaching x from the positive or negative direction or something like that, this is going to be undefined. And especially since we were never given h of x or f of x in the first place to be able to simplify this and figure out if it's actually undefined, we need to say undefined for this one. In this one, we're just combining multiple things together. So I'm going to write this one over here because it might just take a little bit to write out. So first you can see we have a product in the denominator. We have f of x plus g of x squared. So that's saying 1 over limit as x approaches a of f of x plus g of x times the limit as x approaches a of f of x plus g of x. So you see how we turn that product into two separate limits being multiplied together in the denominator. And now each of these limits, we can just use the rule that we used up here for number 1, where you distribute the limit. So I'll just skip a couple of steps here. We're going to have the limit as x approaches a of f of x, so that's going to be 4 plus negative 2 times 4 plus negative 2. So that's going to be 1 over 2 times 2, which is going to be 1 over 4 for this last one here. So those are a couple of limit problems where they want you to break the limit up into multiple pieces. And they use f of x and g of x and h of x, just generic functions that they're making sure you actually know how to split this limit up and not just solve it using algebra and other things like that. So thanks for watching.